Do you all agree with that? All right, now you replace the currents with their what voltages are related to it and the resistances. Follow me? Please make sure you see this. And don't trivialize this stuff. You get relaxed, oh, I got it. You go to quiz, I don't have anything. It happens all the time. People see it in class, and then come to quiz, they're clueless. I don't know why, but it happens all the time. Focus on this now. What is I1 in terms of the voltages? Class? Go ahead, say 12 minus what? Over 1K, right? 1K equals, what is I naught? V over 2K, right? You all see this?
Yeah.
And what is I2?
6 minus V.
A V minus a minus 6. Let's do it that way if you don't mind, because that's minus, right? The minus sign first. So it's V is the voltage on the positive side where the current's entering, minus 6 is the voltage on the negative side. So it's V minus a minus 6 over 1K. Correct, class? We're going to solve this. Y'all agree with me so far?
Yes.
All right, now, this is what I do. When I see something like this, you see K on both sides, don't you, class? 1 over K, I should say.
Yes.
Multiply by K and get rid of it. Don't ever allow K, by the way, in case you don't know, is 1,000. All right? Milli is 1/1,000. Micro is 10 to the minus 6 times the units. All right? Capital M or mega is 10 to the positive 6. Those type of prefaces, you have to know those. And in engineering, we use them everywhere, right? And in physics as well. Now I have that. Probably the easiest thing to do, I don't know if you would like, I mean, we don't have to do much at all now. I can just do this. Get rid of that minus and minus 6 and put plus 6, as some of you have already said. Now we get down to that point, right? Now we take everything to one side, as far as the knowns and the unknowns to the other, and solve for. So what do I get here? I have, well, I can take 12 minus 6, or 6 is equal to V, and it's times 1/2, right? Then plus 1, the minus V comes over, plus 1, or really it's V times 2.5, right? Or that's 5/2, isn't it, class? Isn't it right? Am I right? Right? I got a half plus 1 is 3.5 plus 1 is 5.5, right? 5.5. Now for V, what would it be? V would be equal to, take a look. It would be what? 6 divided by 5/2, or times 2, or 12/5 of a volt. Do you all agree? Class, can you all see me on this, doing this? This is very, I know it's trivial, boring, but I've got to do it this simplistically right now to make sure everybody sees what I'm doing. All right, now that I have that, I'm after the current. What do I do? If that's the voltage here, what's the current? I naught. People? It's simply that voltage, 12/5, divided by 2K. And that would be simply what? 6/5 milliamps. Because 1 over K, 1 over 1,000 is 10 to the minus third. 10 to the minus third is milli, right, class? And the units of current are amps. How many see this right here? It's straightforward. I know it's boring to some of you because you got it. But there are some that are still a little unsure and uncertain about how to go about these things. So I'm doing this in a very simplistic way. That's one. We're going to do another, just to make sure everybody sees it.
What did you say was the conversion, the kilo to the mil?
Well, if you take 1 over, K is 1,000, right? 1 over 1,000 is 1/1,000, right? Or 10 to the minus third. 10 to the minus third is milli. How many know that? All right, I'm sure everybody who's an engineer has understood these prefaces. Yeah?
Oh, no, I was just raising my hand.
Okay. All right,
Wait.
next. I'm going to give you another problem. I'm going to give you a bunch of homework. Yes?
At what time does like the current change? Like when it's going through something, how does that happen?
Well, remember, current in anything in series never changes. Remember that. current actually doesn't change, but the value of current through different elements in the circuit is different based on the voltage across those elements. All right, current is like water in a pipe, all right? If you got 5 gallons per second flowing in a pipe, the only way it ever changes is if there's branches from that, and some goes this way and some goes the other way. All right, that's how current can change. Voltage changes when there's different pressure points you're measuring across. Think of it that way.
So how do we have a less current if we have
You don't. You have current that divides. If you have 5 amps going this way, say 1 amp goes this way, 4 amp goes this way, the same net amount of current is flowing. Okay? Please try to remember that. Next, I've got another one for you. This one's going to be a little different. Here we would need a matrix approach to this one. So I'm going to take 2K ohms here. That's 2K ohms right there. Then I'm going to have a current here of 2 milliamps flowing down. Then I'm going to have a 1K resistance here. And then I'm going to have a 4 milliamp current flowing up. And then I'm going to have 2K here. And what am I after? Oh, I'm after this current, the last thing. I'm after this current right here. That's what I'm after, and I don't know what it is. All right? Hear me on this now. We're going to use nodal analysis. You can't see. All right, what do you need? That's 2K, that's 2 milliamps, that's 1K. I don't put the ohms on a lot of times. 1 ohm, that's 4 milliamps here. This is a 4 milliamp, and that's 2K ohms. And the current here is I naught. Can you all see in the far back? I'm more worried about you guys. All right? Now, if we want that, where do we start, people? First thing.
Ground.
Ground, right. We put a ground in. 0 volts. Because most of the time it's not supplied. After that, the next thing is we identify unknown node voltages. Hear me? Now, there are more than one. We don't know the voltage here. So we'll call that V1. I choose a value. V1, VA, whatever you like. There's another point we don't know the voltages right here. So we can call that V2. You all see that those voltages are not known, right? And a node is defined as an equal potential point where there are more than one way for current to get in and out. You all see that that's basically a T right there. You could have a T, you could have 4 things, 3 things, 4 things, 5 things going in and out of there. Understand? But it's an unknown pressure point, unknown voltage. You all see this, class? People. All right, now we go about and we define currents. Some of them are predefined, right? I always go from left to right and from top to bottom. So I'm just going to call this, for lack of a better term, I1. I naught's being used, right? Then I'm going to call this current right here I2. And now I've defined all the currents, haven't I, class? How many see this? Now you simply write the equations for some of the currents going into those nodes is 0 on these nodes. You can call that node 1 and this node 2. For node 1, what are the currents going into it? Take a look. How much is going in? Is anything going in? That's it. None. So it's 0. This makes it nice. So we've got 0 equals, say it, I1 plus 2 milliamps plus
I2.
Plus I2. You all see that? Class? Right?
Yeah.
All right, now let's keep going. We're not done. What is I1 equal to? People? Say it.
0.
V1 minus 0, or V1 divided by 2K, right? Put the K in, right? And what is, that's 2 milliamps. Just let me finish this. What is I2, people? Come on. Can you all read that? What is that? V1, thank you. Minus V2, thank you. Over 1K, thank you. All right, that's your first equation. Do you all agree with me? Class? All right, now if we multiply through by K, I like to simplify things. My life's complicated as it is. If I multiply everything by 1,000, I get rid of the K's here, right? And 1,000 times milli, which is 1 over 1,000, gets rid of the milli. Agreed? So now the units are all amps, and I don't even need to put it. You with me on this? If you want, you can multiply by 2 if you don't like fractions. Multiply by 2. Why don't we go ahead and do that? And then that makes this 4, right? And then there's a 2 here. Do you agree with me? Now we're going to get one equation with 2 unknowns. I'll collect the coefficients on V1. And here I have 1 plus 2 or 3V1, right? Then I collect the coefficients on V2. It's 2 with a minus sign, minus 2V2. And that would be equal to take the 4 on the other side, minus 4. Take a careful look at that. There's no trickery here. I'm just organizing in terms of something I can put into a matrix. How many see this right here? People, let me finish my train of thought here before you blow out of here, all right? Now what about the next one right here? Go ahead and tell me what currents go into that node. People?
I2.
I2, right?
And
Plus
4 milliamps.
4 milliamps. You all see the 4 milliamps is going into it, right? What comes out? I know. All right, now replace these with the variable, with the unknown voltages, and the known voltages. What is I2? Okay.
Minus V2.
What's it? V1 minus V2 over
1K.
1K, thank you. I'm not hard of hearing, but I did hear sometimes. Oh, plus 4 milliamps equals, what is I naught? People. Over 2K. You all agree with me? Everybody? All right, now just let me finish this before you blow out it. All right. So I'm going to multiply everything by K. Hear me? By 1,000. Gets rid of that, gets rid of that, and gets rid of that milli, because milli is 1 over K, 1 over 1,000. Understand? So now I simplify it down. It has the same units. Everything's in volts. And I know people do this. They like to do this. They don't like fractions. Multiply everything by 2. Make that 8. And then this has a 2 in front of it, right? Now, at this point, you're dying to get out of here. Can you see how you can organize this into a coefficient of V1 plus a coefficient of V2 equal to minus 8, right? And now you have the first equation and the second equation in a matrix form, and by God, that's what your calculators are here to help you with. Now you don't have to do adjunct over determinant to get the answer. You punch the little numbers in your calculator and you can get it. I'll finish on that next time, all right?